seeing your screen.
Yeah, I'm just
Okay,
started to
okay.
share it.
Sure,
Just
sure.
give me 1 second.
Yeah, yeah.
Hope now you can see my screen.
Yeah, perfect. We can see it. Yeah.
Okay, so let me know when you are ready.
Yeah, we are ready. We can start.
Hello, good morning, everybody. This is Rajneesh Kaushikk. We are not here to talk about AI. We are here to talk about what happens after a chatbot. Today, we are stepping into the era of autonomous AI agents and systems that don't just respond, they plan, reason, and then they collaborate with each other. And the best part is that you can build them today with the Azure AI and Semantic Kernel. So this is a very interesting session for all of you. I'm so excited to be part of this session. Before we start, let me introduce myself very quickly. Um, it's a real pleasure to be here today with all the fellow AI professionals. I am Rajneesh Kaushik, and if I have to describe myself in a sentence, I would say that I'm someone who is very much obsessed about AI, with turning ambitious AI ideas into a real world governed system that really works in the production environment. And over the last 2 decades, I have worn many hats, and from debugging the .NET applications to building the modern AI platforms for Fortune 500 companies. And currently, I lead the Databricks practice for Virtusa. And yes, I proudly carry the badge of Databricks MVP, Microsoft MVP, and the Databricks champion. But beyond these labels, let me tell you what really drives me. And you know, the driving force behind me is like, I'm always thinking about that this is an era of AI agents. They are evolving from the scripted chatbot to an autonomous system, and that can make their own decisions, take their own actions, improve themselves. And what we are going to learn today is all about this only, and how we can architect these agents by using the tools which you already have in your tool stack. So let's dive in, because agentic AI is no more a science fiction. It is our next deployment, what we're going to learn today. So I'm very excited to be part of this session. Let's get started. So here is our game plan. First, we will define what real agents are. Then we are going to say that why it matters a lot today, how Microsoft kernel enables this whole idea of agentic AI. And then we will go and onto a hands-on lab where we are going to show you how multi-agent system can plan, and they can also work with each other as a like a digital worker. So let's get started. So first and foremost, um, what is what are the agents? Okay. So let me clear the air and think about chatbot. Generally people think about chatbot as if that they are following a scripts, right? But let me tell you, agents don't follow the scripts. Agents are proactive. They have memory. They have context, tools, and then they can decide how you can expect them to work based on your own expectations. you know so this is a difference. This is a very critical difference between asking a bot to book a meeting for you and agent to plan a conference for you and figure out all the steps on its own. So agent is not just another GPT or a wrapper on the top of a GPT. It is a goal driven system with its own memory, tools, and the ability to take multiple steps in actions on its own. And this is a fundamental difference why agents are important and what it is all about. Okay, so now, what is AI agents? Goal-driven system which contains reasoning, memory, and tool use. So we are at a moment where LLM, memory, and tools have converged together, right? The synergy between all these systems that enables the whole automation fundamentals of process. It is not just a scripted process, it is a smart system. And these systems are adaptable in its own. They can plan, they can act, and this is no longer a science fiction kind of thing, right? It happening with the help of a semantic kernel and Azure AI. And these are the two fundamental tenets of goal-driven systems, right? It has a very fundamental unique capability for reasoning, memory utilization, tool uses. Okay. Now let's understand how they differ from traditional bots and copilots. Okay. So let's understand the key distinction between AI agents and traditional bots. Unlike traditional bots, AI agents can learn. They can learn from the adapt from the interactions which human beings are making with them. They can enhance their effectiveness over the period of time. And this autonomy which is given to them are a very context sensitive. They're a contextual, very aware, contextually very aware about, and this is a real power behind it that enables them to make an informed decision based on the past experience and the learning which they are gaining out of it. And this allows a very complex interactions and task handling. you know Now think about something like unlike a traditional bots. They follow a predefined script, set of tasks, set of flows, and AI agents are actually more capable of learning and adopting those behavior on its own. The process is very provides a very higher level of autonomy in its own, with a very contextual awareness, and this is a very big differentiator. Now let's understand why agentic AI now. Why you want to learn agentic AI? What is special about it? So when we come here, agentic AI, the question is, in the current landscape of technology, if you talk about there is a pressing need for intelligent automation. Because businesses nowadays facing increasing complexity, demand for efficiency, they want timely solutions, and these all fundamental needs are captured by the agentic AI, right? Now, when it comes to relevance and urgency of adopting this technology, today is the time when you have to adopt it in the fast-paced environment. So, demand of automation in a various sectors is growing, and agentic AI is providing all that necessary sauce behind it, which contains autonomy, context awareness, dynamic environment, right? So that's why we are going to delve deeper into this rising prominence of agentic AI in the upcoming slides. Now, as you know, that automation is evolving day by day, and need for system who can understand, who can contextualize, who can adapt themselves is more and more important. Now, contextual understanding, how it helps a agent. Contextual understanding allows this automation to improve the operational efficiency, while dynamic task execution actually helps this agent to plan and then respond in a real-time situation for all the real-time data which is coming from it. Now, adaptive automation also takes the step further. Why? Because it helps you to modify the behavior based on the current environmental factors, which makes it very crucial for all the modern AI solutions. Now, organizations require this kind of automation, not just to execute their task, but to understand how this whole context plan changes dynamically and adapts to a changing environment in the current scenario. Agentic AI fulfills all these kind of needs together in a very cohesive way. Now, let's understand the powerful combination of large language model, tools, and memory agents. And these creates a very effective agent as a bundle. Now, let's see LLM actually, how does it help? LLM actually enhances your communication. It helps your query handling, while integration with the various tools which is already available allows you to in real time do the task execution with the help of API calls. Memory plays a very, very vital role because with the help of memory, you can retain your context. or you can remember your context for the future communication. It improves your interaction over the period of time. And this is a very, crucial for all these powerful agents. Now, a powerful agent should have a capability where it can understand the complex queries, generate the actionable responses, and this is a real synergy and power which helps you to make it more effective for automation. So now you might be thinking, okay, this is good. Now, what kind of agents we have? Why, how can I choose the agent and what kind of agents are available in the market? So this is very, very important and crucial to understand the different type of agents, which is very essential for grasping the full potential of agentic AI. Now, let me introduce concept of single agent system, which focuses on a specific task versus a multi-agent system that collaborate with the more complex task and multiple agents involved into it. Now, this distinction is very, very crucial because this is actually laying the groundwork for foundation for building these kind of agents. And these agents can be based on their functionality. It could be two type of agents, multi-agent and single agents. And let's understand the difference. So the comparison between single agent and multiple agent is that single agents can be efficient for straightforward tasks, and while multi-agent can enhance your collaboration capability with decision-making power and through a very, very specialized roles, right? This collaboration is very, very important because in today's dynamic environment, multiple agents are required. They can work with each other, talk to each other, take the inputs from each other. And this is the real power, which is showcasing the power of teamwork in the AI. Now, single agent focus on a very specific task, while multiple agent involve collaboration among different agents. And these agents could be planner agent, worker agent, and critic agent, which gives a feedback for all this work. And this collaboration is very, very important to make it successful or a real agentic work. So let's understand real world scenarios, why and where you can use real world agents. So focus here is a multiple applications, and you will see that the power of AI, agentic AI, is very, very huge. If you see, these are some use cases, real world use cases. Like for example, multi agents can be very effective in project management, logistics. You can use it for coordination, smart environments. This scenario highlights how these agents can work together to optimize the overall process and then improve the communication for enhanced efficiency. Now, multi-agent system has other than this, there are other real-world applications like in healthcare, CRM. There are lots of different applications, and this field is exploding like anything. So this is very, very exploding field, and lots of opportunities coming up in this. Okay, so before now, by this time, now you understand what is this agentic AI, what is single agent, what is multiple agent, why I need it, right? You are pretty much excited, but then the next question you might be thinking, okay, now how do I build it? That is the second question coming up in your mind or popping up in your mind. So let me give you some primer of what is semantic kernel, which is a tool which you can use to build this kind of agents. Okay, and semantic kernel is a crucial tool for understanding the role of orchestrating these AI agents. And this provides a overarching framework which is very necessary for structuring or for integrating various AI components together. It actually enables the developers to create intelligent agents which is capable of operating together with each other. And semantic kernel is actually a Microsoft SDK, which is very much specialized to design, especially designed for orchestrating the multiple agents. And this also supports a different programming environments. So these are the essential components, and this is one of the very important framework. And if I talk about the comparison of semantic kernel with other frameworks, you will be surprised that this framework is quite popular. Okay. So now you understood that why you need to learn semantic kernel. Okay. But now you might be thinking that, okay, this is semantic kernel, right? And semantic kernel is a framework for various AI components. Now, what can I do with this, right? So you can create intelligent agents. Sorry, you can create intelligent agents. You can perform complex operations for decision making. You can also use this for complex task execution and decision making. So this framework provides you all those capabilities. Okay, so now what are the other silent feature of this framework? The first and foremost, it provides a cross language support, which means that if you are a .NET developer, or you are a Python developer, or you are a Java developer, all these languages are supported by semantic kernel. And then there is a lots of versatility involved in this, right? And you know that AI Python is very, very important language. So obviously it supports Python as well. Now let's understand the core component of semantic kernel. So there are the first and foremost kernel foundation. This is which provides a core functionality of the agentic AI. Then there is a concept called skills. Skill is nothing but a specific capability of agent. For example, a role given to agent, um, and you are going to learn it in the live demo where I'm going to create a agent for different agents and give a specific role for each agent. Then there is another concept called action planning, and this is something where you plan to orchestrate the sequence of actions for an agent so that agent can take those actions to achieve their requested goal. And then the last but not least, the memory storage, where it is required for storing your data, where agent relies on it to learn and adapt and make the informed decision. Or after the agent is restarted, it can start from where it left. So it's very, very important for the memory storage. Now let's delve deeper into the next stage, understanding the kernel core architecture. Okay. Because this core kernel architecture is very, very crucial for understanding it. So now, kernel is nothing but a central orchestrator, which helps you to manage the life cycle of the agent, helps you to coordinate the agent between multiple agents. Planner is nothing but a natural language processor, which converts the natural language goal into the sequence of executable tasks or thoughts or steps, something like a lang chain. Then skill is a discrete unique capabilities where the agent can call a API, it can perform a logic, it can do the LLM prompting so that it can achieve the task. And memory is nothing but a embedding used on the structured memory, which enables the context-aware planning and response for the refinement purpose. So these are the major part of it. And obviously the executor is required so that the executor can execute this thought in a sequence so that it can handle the execution process, as well as if there is a execution interrupted, it can definitely handle the retries on this. Now, what are the other main component like OpenAI LLM as a backend? In this case, we are taking OpenAI as a LLM, and this is very important because the integration of backend enhances this capability of agent to allow them to process the language task very, very easily. So this is a backend, a very, very critical one, and it also helps you to make it contextually aware. Okay, so now let's understand more detail about planner, memory, and skill and core reasoning modules. So planner, how does it work? You will be surprised that if even as a human being, we think about any task, how do you think about it? You plan it. First, suppose, for example, I am going from step A to step B. So in that case, I'm going to, decompose this task into multiple parts. First, I'm going to go catch a taxi. Second, I'm going to go there. Third, I'm going to drop down there and then go by walk. So these are the three tasks which I am decomposing it. Similarly, agent required to decompose this in a goal, and then it systematically navigate to that goal and create an action step to achieve that goal. So these are the step of a planner. Now memory. Memory's role is very, very important for context. It's a central repository for storing a context. providing essential data for the agents. There is a concept of embedding, which you or might already be knowing that what is embedding. Embedding is nothing but a method where the data is transformed into the numerical format so that machine can understand it. And then vector search functionality where it helps agents to quickly access the relevant information and enhancing this decision making process. So these are the memory, embedding, and vector search. So vector search is very, very critical because machine cannot understand, the natural language. So it need to convert that into a uh, numerical way so that it can understand it. Okay, now agent is we are creating an agent. Now let the next question comes, how you are going to call or create a skill. So skill is nothing but a custom functions which agent can call on your behalf. For example, if I want to book a travel itinerary, then I can call Expedia agent, which can call a RESTful API to create that ticket for me. So this is something like a skill. And it is very important for skill to access the external information. And external information could be accessed with the help of API or a custom defined function which calls the external database or external API or external system. So this is how the skill works. Now, what is Azure AI integration? The combination of Azure OpenAI, prompt flow, plugins, and Azure functions create a very robust architecture or ecosystem for executing this whole complex agentic workflows. And in this, we are going to learn about how do we integrate these components together to make a very scalable solution for various requirements, very varied requirements, right? Now, integrating Azure AI with semantic kernel is very, very crucial for comprehensive agent orchestration. And in this section, we are going to cover more, and also I'm going to show it in a demo. So now, as you know that these technologies like integration of technologies, for example, OpenAI works very seamlessly with the prompt flow plugins and Azure functions. Create a powerful ecosystem. Agent driven task, it provides a very robust infrastructure for executing a very complex task. And it is not just executing this task, but it also is very important to make it a more scalable infrastructure. Why? Because you are not going to work with a one or two person. There will be thousands of people calling these agents, and you want to make sure that this whole infrastructure is scalable. Okay. So now let's understand the whole concept, what we have learned. Enough of theory. We are going to understand it with the help of a demo. And before I can show a demo to you, I'm going to just create, make you understand about the use case. So now in this demo, what we are going to do, we are going to create a agentic AI, where we are going to plan an AI meetup. And in this, we are going to ask the venue selection, where we are going to select a venue based on the requirement. For example, I want to, create a AI meetup in Pune. So when I'm going to tell that I'm going to create a AI in the Pune, it is going to let me know the venue selection. Then it's going to draft the agenda for me, and then it is going to suggest the speaker. For example, if I want to schedule a SharePoint or M365 in Pune location, then it's going to maybe tell me the suggested speaker name as Nandeep, right? And it's going to tell me that some it's a venue in the nearby hotel, right? So these are the things which is going to do based on the user inputs. Now, the whole concept of the whole agentic AI we are developing here is first is a searching for venues. So first you are going to search the venue. So if you talk about any fundamental scenario where suppose I'm telling you to I want to conduct a workshop in Pune. So the first and foremost step what you are going to do, you're going to Google, ask where is the nearby hotel or nearby venue, and then based on that you are going to suggest me something. But in this case, agent will do this work for you. Then you are going to draft the agenda, because without agenda, it's very difficult to put the whole AI meetup, right? So that AI agenda is very important. And based on your information you are providing, it's going to outline the topics, which is very relevant, and it's going to schedule the sessions, in a well-structured event. And that is what we do, right? I mean, for example, this event you are conducting, this same event which you are conducting, there are lots of hard work done by Nandeep and team, and they are exactly following these steps: searching the venue, drafting the agenda, and then suggest the speakers from the industry who are nearby or who have this interest. So this is what we are going to develop. Now I'm going to show you the demo. Here in this, I'm going to use a semantic kernel. I'm going to use a Azure OpenAI, simple plugin functionality, and memory components for retaining the memory. So there is a live demo. Let me share my screen here. This is our agentic AI demo. It's coming up. Starting the app. Yep, it is there. So as you can see, let me introduce how this whole app works. So first and foremost, we are going to set up a event planning system. This is a event planning system. Okay. And in this case, first and foremost, I'm going to initialize my system with the help of Azure OpenAI. And obviously you can use any other endpoint and model and then API version. So now my event is initialized now. Now when I come to event, I want to execute this AI innovation meetup in the city of San Francisco. Instead of that, I'm going to tell that Pune, for example. Okay. And then I'm going to say that expected audience is 75. Focus area is machine learning, ethical AI, computer vision, and budget is $2,000, for example, right? And I'm going to save this. Now this details are saved, and then I can move to the venue selection. Now in this venue selection, now here I can find and analyze the different venues. So here are these venues. Here are these venues which is providing it. And these are the event information it is using. So once I find and analyze this event, it is also providing me the details about analyzing the tech innovation hub, modern environment, tech friendly setup, and these are the pros and cons of this particular, right? So it's telling me that, these are the pros and cons of this event. Okay. The venue. And then this is a higher cost, limited parking, but this is user friendly, modern environment and central location. So you can pick and choose anything which you want. And this is where the address is, Pune location, right? And then there is another one, where this another location is there. And then this is another location. So like these are the venues available, and there are for each of these are the amenities available. So it's automatically providing me. So now I'm good with this. Now I can go to the agenda creation. So I'm going to ask it to create an agenda, and it is creating an agenda for 3 hours, where target audience is mixed, focus area is this, which I've already provided. And then you can, keep on adding the schedule. So after this, I'm going to ask, okay, what is the speaker suggestion? So it's going to give me the speakers based on whatever information I have fed into it, but obviously it can go into internet and do all that expertise. So in this case, it is telling me these speakers and their expertise level and speaking experience, and each of these speakers have their own. And then it also provided me a speaker email where I can copy paste this email and send it to each of these speakers, right? And then finally, when I come to the planning part, and I can generate a comprehensive event plan end to end, It is generating that comprehensive event plan with the executive summary, attendees, and then event schedule, and then for each of these speakers, what are the expertise, and then all their details. And then you can download it as a full plan. So this is the whole agentic, so now let me tell you what we have built and why, how we have built it. So if you talk about here, this is a semantic kernel. And in this, there is a event coordinator, which is nothing but a planner or coordinator agent. Okay. And then we have these different agents, description agent, which provides a description of the event, which provides you this, different descriptions. Um, then, sorry, my bad. This is plugin. This is a description asset. Sorry, this is the plugins. So description is nothing but a different assets used in the UI. And then these are the agents. Agent drafting, which is a drafting the whole agent, the event drafting. And then there is a speaker suggestion agent, and there is a venue selection agent. So these are the agents which is working together as a team, and these are coordinated with the help of a coordinator agent, which is an event planning coordinator agent. And the whole concept is that we are actually creating this venue selection agent with the help of a kernel method. Like if you talk about this, these are the methods in the kernel. Um, you know, so there is this kernel function search venue, which searches the venue item, venue, different venues available. And then same way we have an analyze venue, which analyzes this. And it's pretty easy because if you talk about here, it's just a plain simple Python code with some decorators, and it's pretty easy and straightforward, right? So this is a fundamental way you can develop any complex agent, and not just develop it, but they are talking to each other in real time with the help of plugins, right? They're talking to each other there, and then there is an event which is coordinated by these, the top-notch coordinator agent. Okay, so now let's quickly go to the next part. So now this is what we have done, right? I just explained you that this is actually accepting the goal, running the planner on the top of it to break down the task into multiple manageable tasks, executing the skills with the help of plugins, which I just explained you, and presenting the composed result in the final answer. So these are the goal achievement, real-time orchestration, and efficient task execution. This is what we just developed. So here the specialized agent plugin, three distinct agent plugin coordinator layer, OpenAI semantic kernel, right? So coordinator is actually workflow manager. Semantic kernel is a framework which it is using. Azure OpenAI is a reasoning engine, and menu selection agent and agenda drafting agent and speaker suggestion agent. These are the three agents which we are using. And how do we develop it? First, we are going to initialize this kernel. Then we are going to run the agent registration. And in agent registration, we are going to register those agents to the kernel. Then we are going to sequence this agent innovation. So these are the sequence, that, first we are going to select the venue, then you're going to draft the agenda, then you're going to suggest this. So this is a sequence. And then there is a data sharing happening between the agents so that they can share the data. And this is whole comprehensive plan which is getting generated as I showed you. So it is a specialized expertise for each agent, modular, extensible, and single-handedly handling those skills, and it's handling with each other a very intelligent way. So these are the couple of architecture patterns evolving from it. First is there are these reactive versus proactive agent. In this case, you have this reactive agent which support respond to a stimuli in the real time, while proactive agent take the initiative based on its goal. Sequential and parallel skills, Sequential skill, involve one skill at a time, one after another. Parallel can do the multitasking. And memory grounding strategies, where memory grounding strategies, help you to understand how the agent can store and use this information, and that actually impact the overall learning and decision making process. Now you might be thinking, okay, now I have developed the agent. How do I deploy it? Because deployment is a very, very important part. So for deployment, there are multiple options. Azure Container App can be used. Azure Functions you can use. Azure Kubernetes Services, again, another flavor of Kubernetes. And then prompt, you can use prompt flow for monitoring. So these are the deployment considerations for agent. Whenever you now, if you deploy these agents into a large scale enterprise system, there are lots of other aspects you need to think about. First and foremost, tool safety. You need to ensure that tool used in the enterprise deployment are pretty safe, secure, and they are protecting the sensitive data. You cannot afford to expose this data to the outside world. You need to also make sure that you are evaluating the feedback or loop. Why it is important? Because if suppose some agent provide you an answer, and if there is no which is not correct, then there should be a feedback mechanism, and tagging that feedback it should be there. Plugging contracts. You need to make sure that there is a compatibility and seamless integration of all these tools, right? Okay. And then observability and governance, because now after you deploy it, you need to make sure that this whole solution is governed and it is observable by the monitoring tool so that nobody can misuse these agents. So with this, I think we have covered all the agentic AI related scenarios with the semantic kernel. The floor is open now for any questions if you have any. Uh,
Okay, let me stop